Today we're going to be able to graph and interpret slope-intercept form equations from real-world problems. And remember when I talked about your test, how I said that one of your test problems was going to be, you'll be given a word problem. Your job will be to write an equation, graph the equation, and give me a t-chart for that equation. And it doesn't really matter what order you do those things in, but it does matter that you can do all of those things for the same problem. That's exactly what we're doing today. We're starting with a word problem, and we're going to be asked to go ahead and graph that word problem. So in order to do that, we can do it a couple different ways, but usually the first step that most people want to take is writing the equation. That doesn't necessarily have to be true. So looking at this, it says Mr. Hannibal is purchasing new basketballs for the team. The flat rate shipping is $10, and each ball costs $15. So we want to write and graph an equation to represent the total cost of getting the balls based on the total number of balls that he buys. So, with that being said, we can write an equation from this. We could actually probably start making a t-chart from this. It really doesn't matter what order that you do it in. So with this one, we'll start with the equation, and then we'll move forward from there. So let's look at this. How would I go about writing this equation? Yep, so Edgar wants to start by writing down the rate, which says it's $15 for one ball. Or he can write it the other way. One ball is $15. So what are the units of our y going to be? Y is going to be what? Dollars or balls? Dollars, because we can see we actually have to end up over here with dollars. And this makes sense because the number of balls is the independent variable, because we can change that, and then that will change the price. So matching that up, I'm going to get $15 per one ball. And then I need to multiply that by X number of what? Balls. But if we, where do we start though? What does the price start at? No matter what, no matter how many balls, I'm going to always have to pay what? $10. So check our units here. We have dollars equals dollars plus dollars. All right, that makes sense. Let's go ahead and write our equation. Y equals 15x plus 10. All right, so we could have started with the equation, or we could have started with the t-chart. Let's create a t-chart over here. If I ask them to ship 0 balls, what's it going to cost me? $10. That's my starting point. That's my y-intercept. And that makes sense because if we came back down to our equation, that's definitely the first point that we could have come up with. All right, if I buy one ball, how much is it going to cost me? Not 15, because it's the $15 plus the $10 of shipping. Next one. If I buy 2 balls, how much is that going to cost me? $40, because pay 15 for each ball, that's $30 plus the $10 of shipping, $40. And what we can see here is we could have started with our t-chart, and then we could have gone, well, what's the slope? Well, this is a change of 15 and a change of 15. And our change in x is 1 and 1. So our change in y over change in x is equal to 15 over 1. Which, sure enough, our equation in slope-intercept form right down here has the slope as the same thing, 15 over 1. We also see the y-intercept up here, 0, 10, has the same y-intercept that we have down here. So you actually could have created the t-chart first and then used the t-chart to make your equation. Now let's talk about graphing it. We can graph it from the t-chart, or we can graph it from the equation. Now, when I start to look, though, at my grid that I have here, what's going to be the problem with graphing this as we see the grid right now? What's going to be the problem with graphing this? Giselle? Yeah, the numbers are too big, so we're going to have to change our scale a little bit. What do you think that we should count by on the y's? Sammy?
We should count by fives.
So he wants to count by fives, and what do the y's stand for? Because we're going to go ahead and label this axis. What do the y's stand for?
10.
Dollars.
Dollars.
That's how much we pay.
Yeah.
And the x is what? Balls. All right. So he said that we should count by 5. So what I'm going to do is I'm going to come over here, and I am going to count by 5s. I'm just not going to label every one. So I'm going to skip the 5 and label the 10. 15, label the 20. 25, label the 30. 35, label the 40. And 45, label the 50. So I'm still counting by 5s. I'm just not labeling every one because I just don't quite have enough space to make that happen. And I'm going to do the same thing in the negative direction. Negative 10. Negative 15, negative 20, negative 25, negative 30, negative 40, and negative 50. Keep yes or keep no. Do you think that we need to change our scale in the x direction? Yeah, so what we can see here is that our changes in x's are in ones. So that's actually going to be really easy. I'm going to go ahead and, just so there's no confusion, I'm going to label them just so we make sure that we know that I'm still going with counting by ones over here. So I'm going to label some of those. All right, now we can go ahead and graph our first point. We could graph our first point from the equation. The equation tells us that our y-intercept is what? The equation tells us that our y-intercept is what? The equation tells us that our y-intercept is what? 10. All right, so 0, 10. And sure enough, we can see that's also the first point from our t-chart. Our equation tells us that we have a change in y and change of x, a slope of 15 over 1. And so that means that we need to rise 15, 5, 10, 15, and run 1. Why does it look like I only rose 3 when my change in y is supposed to be 15? Why does it look like I only rose 3 when my change in y is supposed to be 15? Jasmine? Yeah, since our scale is counting by 5s, to get 15 rise, we only have to rise 3. Okay, so I can follow that again. 5, 10, 15, run 1. And this is going to be our line. And we notice these are actually the exact same points that we could have graphed from the t-chart. So you can create the t-chart and then graph the points on your t-chart, or you can graph it using slope and intercept. It doesn't really matter. On your test, I'm not going to force you to do it one way or the other. You have to do whatever works best for you, because the point of the test is going to be, can you mix these different ideas? All right, so it says how much would 3 balls cost? Well, there's a couple different ways we can do that. I could plug 3 in for what? X or Y? I could plug 3 in for x. Thank you, Edgar, for being the one person participating. I could come over to my t-chart and I could find where x is 3. I don't see that on my t-chart. Or I could come over to my graph and I could go up from 3 and see where it connects with my line. And the problem with that is it's off my grid, so I can't actually really tell where that is. So in this particular case, our best solution and our best way to figure this out is to plug it into the equation. We're going to get 3 times 15, which is 45, plus 10 more would be 55. Now, thinking about the graph itself, do the negative portions of the graph make sense in the real world problem? So sometimes your x's will make sense and your y's will not make sense, or the other way around. So let's think about it. Let's think about just my negative x values. Negative x values. My x values stand for the number of balls he purchases. Does it make sense in the real world that he can purchase a negative number of balls? This is where you should be responding with a KIPP yes or a KIPP no. Does it make sense that he can purchase a negative number of balls? No, in the real world this actually doesn't make any sense. Alright, let's think about our negative y values. This is when the dollar amount that he's paying for his order is less than 0. Is it possible that he could order something in the real world and have the amount of his order come out to something that's negative? So yeah, so I hear Sandy saying, yes, if they pay me to take these things from them. And in the real world, are you going to go to the store and the store's going to be like, you know what, take these balls and please take this $10 to go with it. I don't want it and I don't want the money. That's not going to happen. Even if you have enough coupons to be like negative something, they're just going to say, you keep the rest of that coupon, that's yours. All right? So in this particular case, no. Negative costs and purchasing negative balls doesn't make sense. All right. So let's look at the next one. We can start with the T-chart on this one, and if he works 0 hours, what is his net worth? Negative 30, because he owes the bank $30. All right? Now, if he works 1 hour, he's going to gain $5, which means that his net worth is going to be negative 25. If he works another hour, he's going to get another $5, which means his net worth is going to be negative 20. Now, we could think about this, and I'm completely ignoring the word problem right now, because I can write this equation with simply this T-chart. I can calculate my changes in Y. Each of my change in Y is what? 5. Plus 5. Each of my changes in X is 1. Plus 1. So that tells me that my slope, or my change in Y over my change in X, is equal to positive 5 over positive 1. I also happen on this T-chart to have my y-intercept, which means my y-intercept, or my b, is equal to what? Yeah, right here, in here, negative 30. which means that without thinking about the units in this particular case, because we made a nice t-chart to start with, we can just plug into y equals mx plus b. We can get y is equal to 5x plus negative 30. If you can think through the problem that way, and you can set up the t-chart, and you can show me the change in y over change in x, you don't have to show me all the unit stuff. If you prefer to do the unit stuff to get your equation first, the way that Jaquan does, and then you want to create your t-chart and your graph, do it that way. It doesn't really matter, as long as you can see the relationship between the different things. All right? Now, if we want to graph it, I'm running into the similar problem that we had in the previous one, and that it doesn't look like I have enough room. So in our y direction, what would you like to change the scale to? What would you like to count by? What would you like to count by? Go down here and label these. And again, I'm just going to label every other one here. Counting by fives, negative 10, then negative 20, then negative 30, then negative 40. Going up 5, 10, 15, 20, 25, 30. I'll go ahead and stop there. And in the x direction, you said that we were going to count by ones. I'm just going to label every other one. 2, 4, 5, 6, 7, 8, 9, 10. Negative 2, negative 4, negative 6, negative 8, and negative 10. All right, so I've got this all labeled up now. And we can graph this any way we want. We've got several points on a t-chart. We could just graph those points. We can graph our y-intercept, 0, negative 30. And then we can follow the rise over the run. Okay, so our change in y is a positive 5. Why did I only go up one box? My change in y is 5. Why am I only going up one box? 1. Yeah, because it's counting by fives. All right, so we're moving forward one box. Change in y is 5. Change in y is... And we can see that these are actually the same exact 3 points that we had in our t-chart. And now we can go ahead and graph with a straight edge, because we're going to be using this line to help identify some things later. As you can see, without a straight edge, it's rather difficult. And now we can use this graph to answer a few things. How many hours will it take him to break even? What does that mean, to break even? What does it mean to break even? Terrence, what does it mean to break even? Yeah, make it so he doesn't owe anything, but the bank doesn't owe him. He and the bank are even. Nothing owed, nothing being paid out. All right, so that's going to be what happens when y is equal to 0, when he has his net worth is equal to 0. So as I come over here, and I see where y is equal to 0, I see that it happens where x is equal to 6, or the number of hours he's worked is equal to 6 hours. All right, so what does it mean when y is equal to 0? We just talked about that. What does it mean when y is equal to 0? Jasmine, what does it mean when y is equal to 0? What does it mean in this problem when y is equal to 0? What are we talking about, Sammy?
They're even?
Yeah, they're even. He owes nothing. He owes nothing. But he also has nothing. When his net worth is equal to 0, he owes nothing and he has nothing. What is his net worth if he only works 4 hours? So we could plug that into our problem. We can look for that value on our t-chart, or we can come down from here where we have 4 hours and see where it intersects our line. Looking at where it intersects the line, when he works 4 hours, how much does he, what is his net worth? Dahlia? Negative 10. Kip yes or Kip no? Do the negative values make sense for this real world problem? Don't be so fast. Think about it in terms of your x's and your y's. Looking at my negative x's, this would be negative hours. In the terms of this real world problem, does it make sense that he's worked negative hours? I would take an argument either way. I would say that if you interpret this problem and you're thinking about negative going back in time, and you assume that he's been working for this job for many hours before that, and he used to have an even greater debt to the bank, I would say the negative x values could make sense. So negative 1 would be when he, an hour ago, before he worked an hour. Negative 2 could be like 2 hours ago before he worked 2 hours. What was his situation? That's making an assumption about him having had this job for a while and that he owed the bank more money earlier. That's one way to think about that. So I would say it's conceivable that the x values could be negative. And here, the y values being negative definitely makes sense because this is where his negative net value is, because that's where he owes the bank. So I would say, do the negative portions of this graph make sense? Why or why not? You can definitely write whatever you need to for x and y. I want you to go ahead and do this on your own, depending on your interpretation of the problem for the x values and for the y values. Why or why do they not make sense? So go ahead and write that on your own.